The Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding ones, usually starting with 0 and 1. The sequence begins 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. The Fibonacci sequence has fascinating mathematical properties, and its occurrence in nature is often associated with the arrangement of structures, patterns, and proportions in various living organisms. Here are some examples of the significance of the Fibonacci sequence in nature. 1. Phyllotaxis, leaf arrangement. The Fibonacci sequence is often observed in the arrangement of leaves on a stem, a phenomenon known as phyllotaxis. In many plants, the number of leaves at a given level of a stem corresponds to a Fibonacci number. This arrangement is thought to optimize exposure to sunlight and minimize shading among leaves. 2. Flower petal arrangement. The arrangement of petals in many flowers also follows the Fibonacci sequence. For example, lilies and irises often have 3 petals, buttercups have 5, delphiniums have 8, and so on. This pattern is associated with efficient packing of seeds and optimal access to pollinators. 3. Pine cones and pineapples. The spirals in the scales of pine cones and the eyes of pineapples often follow Fibonacci numbers. The arrangement of these spirals allows for efficient packing and space utilization. 4. Sunflowers and seed heads. The seed heads of sunflowers exhibit spirals that follow the Fibonacci sequence. The pattern ensures that seeds are packed efficiently and uniformly, maximizing the number of seeds within the available space. 5. Nautilus shells. The chambers in the shell of the nautilus, a marine mollusk, are arranged in a logarithmic spiral that corresponds to the Fibonacci sequence. This spiral pattern helps in buoyancy and efficient growth. 6. Pinecone seeds and pineapple eyes. The arrangement of seeds in the center of a pinecone or the eyes of a pineapple often follows a spiral pattern based on Fibonacci numbers. This arrangement ensures optimal packing and distribution. 7. Fibonacci rectangles and golden ratio. If you create rectangles based on Fibonacci numbers and draw quarter circles inside them, the resulting pattern approximates the golden ratio. The golden ratio, often represented by the irrational number phi, is approximately 1.618 and is considered aesthetically pleasing. It appears in various aspects of art, architecture, and nature. 8. Spirals in shells and snail shells. Many seashells, such as the chambered nautilus and snail shells, exhibit spiral patterns that align with Fibonacci numbers. These spirals aid in shell growth and structural stability. 9. Branching patterns. The branching patterns in trees, such as the arrangement of branches, stems, and twigs, may exhibit Fibonacci numbers. This pattern allows for efficient nutrient distribution and exposure to sunlight. 10. Spiral galaxies. In astronomy, spiral galaxies often exhibit spiral arms that follow logarithmic spirals, reminiscent of Fibonacci patterns. This structure is shaped by gravitational interactions and rotation within the galaxy. While the occurrence of Fibonacci numbers in nature is intriguing, it's essential to note that the connection is not always perfect, and deviations occur. The significance of the Fibonacci sequence in nature highlights the optimization and efficiency achieved through certain mathematical patterns in the growth and arrangement of living organisms.